Every single day, we're just bombarded with claims, right? Lose 10 pounds in a month. This new software will double your productivity. But how do we actually know what's real and what's just, well, hype? Today, we're going to pull back the curtain on a super powerful tool that lets us put these claims on trial. Okay, let's get our hands dirty with a classic example. A health club is running ads claiming new members lose 10 pounds in their very first month. Sounds amazing, but should we believe them? Instead of just taking their word for it, we're going to act as judge and jury and put that claim on trial using the power of statistics.
And that brings us to our first big idea, looking at decisions like they're a courtroom trial. The whole concept here is that we can put any claim, any idea, in the defendant's chair and use data as the evidence to make our case.
Think about it. When the stakes are high, whether it's your health, your money, or a huge business decision, just going with a gut feeling isn't going to cut it. We need a formal, structured way to look at the evidence objectively so we can make the best call, even when we're dealing with uncertainty.
So every trial needs a defendant, right? Well, in statistics, the defendant has a very specific name, the null hypothesis. This is the original claim, the status quo, the idea that we're putting under the microscope.
The easiest way to think about the null hypothesis, and you'll often see it written as H sub 0, is that it's the innocent until proven guilty of the statistics world. We start by assuming the claim is true, and the burden is on our evidence to prove that it's not.
And of course, if you have a defendant, you need a prosecutor. And that's the alternative hypothesis, or H sub 1. This is the challenger. It's the new theory that says, nope, I think the original claim is wrong, and here's my idea instead.
So let's bring this back to our health club. Here's how the trial is set up. The null hypothesis, the club's claim, is that members lose an average of 10 pounds or more. But our challenge, the alternative hypothesis, is that the club is exaggerating, that members actually lose less than 10 pounds. The courtroom is now officially in session.
All right, the trial is set. We know who the defendant is and we know what the prosecution is arguing. Now it's time to bring in the evidence. Let's talk about how we actually collect and weigh that evidence.
Now, we obviously can't track every single member who has ever joined this club. That'd be impossible. So instead, we take a sample. We randomly pick, say, 36 new members and see how they did. And here it is, our key piece of evidence. This group lost an average of only 9.2 pounds.
And this right here, this is the million-dollar question. Sure, 9.2 is less than 10. But is it significantly less? Or is it possible the club's claim is true and we just happen to pick a group of people who had a slightly off month? Is this a real difference or is it just random noise? To answer that, we need a brilliant little tool called the p-value. The best way to think of it is as a surprise meter. It answers one very specific question. If the club's 10-pound claim was actually true, how likely would it be for us to see a result like 9.2 pounds, just by pure luck? A really low p-value means our result is super surprising, which makes that original claim look pretty suspicious.
So we run the numbers for our health club sample, and boom, we get our p-value. It's 0.0228. Okay, it's a small number, but what does that actually mean?
Here's what it means in plain English. If the club really is helping people lose 10 pounds on average, there's only a tiny 2.3% chance that we'd randomly pick a group of 36 people who did as poorly as our sample did. That's really unlikely. It's a surprising result. The evidence against the club's claim is starting to look pretty strong.
Okay, so we've got our evidence, and we've used the p-value to measure just how strong that evidence is. Now it's time for the jury to make a decision. It's time to reach a verdict.
Now, in any trial, you need a standard of proof. You've heard of beyond a reasonable doubt. Well, in statistics, we set our own standard, and we do it before we even look at the evidence. It's called the significance level, or alpha. Think of it as our line in the sand. A really common choice is 5% or 0.05.
This all leads to a really simple decision rule, and there's a fantastic little rhyme to help you remember it. If our p-value, our surprise meter, is lower than our preset standard of proof, alpha, we decide the evidence is strong enough. So the saying goes, if the p-value is low, the null must go.
This whole process, which can sound really complicated, really just boils down to 4 straightforward steps. 1. State the competing claims. 2. Go get your evidence. 3. Measure how surprising that evidence is with a p-value. And 4. Make the call by comparing your p-value to that line in the sand.
So let's deliver the verdict for our health club right now.
Our evidence, the p-value, came in at 0.0228. Our standard of proof, alpha, was 0.05. Well, 0.0228 is definitely less than 0.05. The p-value is low, so the null must go. We reject the club's claim, the verdict is in. Based on our evidence, we do not believe the club's advertising.
But hold on a second. Remember, our decision was based on a sample of 36 people, not everybody. We're dealing with probabilities here, not certainties. And that means, just like in a real-world courtroom, there's always a chance the jury got it wrong.
And there are two very specific ways we can be wrong. A type 1 error is when we reject the claim, but it was actually true. That's like convicting an innocent person. On the flip side, a type 2 error is when we don't reject the claim, but it was actually false. That's like letting a guilty person walk free. Knowing these risks is a huge part of being a responsible data detective.
So we've gone really deep on this One Health Club example, which is great. But let's zoom out. Why is this whole process so incredibly important in the real world?
Well, it turns out this framework is basically the engine of modern science and business. It's how scientists test if a new medicine is effective. It's how companies A/B test their websites to see which version gets more clicks. It's used in factories for quality control and by governments to see if a new policy is working. This process is happening everywhere, all around us, all the time.
Ultimately, what hypothesis testing really gives us is a structured, powerful way to move past our gut feelings and challenge our own assumptions. It's the difference between saying, I think this works, and being able to say, I have evidence to show that this works.
So the next time you hear a big, bold claim in an ad or a meeting, you'll know the secret. You have the framework to think like a statistician and put that idea on trial. So I'll leave you with this question. What's an everyday claim that you would put to the test?